Dear student, welcome to my channel. This is the 7th video on CSS, cryptography and system security. In this video, basic terminology of cryptography is discussed. Now let us start. Cryptography, cryptanalysis and cryptology. Cryptography is nothing but transmission of secure data over insecure channel. It includes study of different encryption schemes and methods. Encryption technique form a cryptographic system. Cryptanalysis techniques for deciphering a message without prior knowledge of the encryption detail. It is nothing but breaking the code. Cryptology is nothing but both cryptography and cryptanalysis form the cryptology. Plain text, original message which is to be encrypted. Cipher text, encrypted, that is scrambled message. In ciphering or encryption, the process of converting plain text into cipher text. Encryption algorithm which performs the encryption. Deciphering or decryption, recovering a plain text from cipher text. Decryption algorithms, it performs decryption. Two inputs are there, plain text or cipher text and secret key. Secret key, same key is used for encryption and decryption when we use for the symmetric key crypto system, also referred as symmetric key, single key, conventional encryption. Ciphers, symmetric cipher, same key is used for encryption and decryption. In asymmetric or modern cipher, different keys are used for encryption and decryption. Block ciphers, which encrypts a block of plain text at a time. So block is generally of typical 64 or 128 bits. Stream cipher, it encrypts the data 1 bit or 1 byte at a time. Cryptographic system, 3 independent dimensions. Cryptographic systems are characterized along 3 independent dimensions. So dimensions are the type of operation for transforming plain text to cipher text. So substitution and transposition methods are used. Number of keys used, it may either symmetric or asymmetric encryption system. How the plain text is processed, either block or in string manner. We will see the each dimension in detail. Type of operation for transforming the plain text to cipher text. All encryption algorithms are based on two general principles, that is substitution and transposition. In substitution, each element in the plain text is mapped into another element. For example, Playfair cipher substitutes a pairs, that is diagrams of letters, and rearrange them. Next is transposition. Elements in the plain text are rearranged. The fundamental requirement is that no information be lost, only the text are rearranged. Relfin cipher example. It works by writing a plain text on alternate line across the page and then reading of each line in turn. So the pattern will look like rail fence. For example, if the text is ABCD, so we write A, B, then C and D, and we will concat like AC and then BD. Product system involves multiple stages of substitution and transposition, and product systems are used in DES and AES. See the example DES, data encryption standard. It uses multiple rounds of substitution and permutation for robust encryption. Second dimension is number of keys used. If both sender and receiver use the same key, then the system is referred as symmetric, single, secret key or conventional encryption. If the sender and receiver use different keys, the system is referred as asymmetric, two key, public key or asymmetric encryption. How the plain text is processed, this is the third dimension, either in block or either in stream. Crypto system. Crypto system is a 5-tuple P, say P, C, K, E and D, where P is nothing but the plain text space, set of all possible plain text, cipher text space C, set of all possible cipher text, key space K, set of all possible keys, E is nothing but set of all possible encryption rule. D is set of all possible decryption rule. So for each k which belongs to the set of capital K, there is an encryption rule EK which belongs to this capital E, and corresponding decryption rule DK which belongs to this D, such that when we encrypt X using the encryption algorithm, and on that encrypted text, this is nothing but the cipher text, when we apply the decryption algorithm, this EK and DK cancel each other and we will get our original plain text which belongs to the capital P. Each encryption function EK and each decryption function DK should be efficiently computable. An opponent, upon seeing the cipher text string Y, should be unable to determine the key that was used or plain text string X. So for example, if input is X and if we apply the encryption algorithm to get the Y, so at that time it should not be easy task to determine the key K, because from using the key K we are transform the X into Y. So it should be difficult to determine the key, and it should be also difficult to determine the X from by seeing only Y. Symmetric encryption. Symmetric encryption, that is a key shared between sender and receiver. It is called as a conventional, secret or single key. Sender and recipient share same common P. It is called as symmetric. The only one type of ciphers prior to the invention of asymmetric key ciphers in 1970. So these are nothing but the conventional or old crypto system in which key shared between sender and receiver. So they were famous or invented before asymmetric key cipher, by far most widely used. Now see, this is example. Here the two parties are there. One party is Alice, second is Bob. This is source, this is destination. The key is shared between the Alice and Bob over the secure channel. This is key. Now for input X, the key is used, and by using the encryption algorithm which takes the two inputs X and K and converts the X plain text into the Y cipher text. Then now this channel is insecure channel, and the Oscar, which is eavesdropper, can see the message. So the attacker can try to find out the key, but if key is found, then it is very easy to decrypt the future messages because key is known. Here K cap is given because it is finding out, or it is nothing but the estimating the possible key. And if eavesdropper or Oscar is successful in finding out the X cap, that is nothing but from Y it determine X cap. So at here it is not exactly X because it is estimating, so it sometimes correct, sometimes may not be exactly correct. So here only for this Y it will get the X, but not for the all future messages. And once Y is reached to the decryption algorithm, so input is Y and K, and using that key K, it decrypts and get the original plain text X to the Bob. Kerckhoff principle. The adversary knows all details about a crypto system except the secret key. Kerckhoff's principle is a fundamental concept in cryptography. It states that security of the cryptographic system should not be rely on the secrecy of the algorithm, but it should be based on secrecy of the cryptographic key. A good cryptographic system should remain secure even if algorithm used is known. So that is nothing but this principle. Now we'll see the cryptanalysis. The process of attempting to compute a key given a string of cipher text is called cryptanalysis. If opponent can determine K, then he can decrypt Y, just as Bob apply the decryption algorithm using DK. Determining K should be as difficult as determining the plain text string X given the cipher text string Y. Recover X by generating the plain text estimate X dash if the attacker is interested only in the particular message, but if attacker will try to estimate the K hat for this K, then the opponent is interested, or the hacker is interested in being able to read all the future messages, because once the key is known, it can decrypt all the messages. This is the diagram for the symmetric key encryption where the key is shared between the sender and receiver. So this key is shared between both the parties. This plain text S. Then encryption algorithm will take the two parameters, that is k comma x, and by applying the encryption function we are getting the y, and at the receiver side it is using decryption function in which again k is there and y, and it will give the x. Algorithm is publicly available according to Kerckhoff principle, and key is shared between the sender and receiver. Now we'll see the cryptanalysis by attack type. The objective is to recover the plain text of a cipher text, or more typically to recover the secret key. Two general approaches are there. One is brute force attack and second is non-brute force attack. But brute force attack is not efficient, so generally the hacker will go for the non-brute force attack. Cryptanalytic attack. This attack relies on the nature of the algorithm plus some knowledge of the general characteristics of the plain text or some simple plain text ciphertext pairs. It exploits the characteristics of the algorithm to attempt to deduce a specific plain text or to deduce the key being used. So here we are seeing the nature of the algorithm plus some knowledge of the general characteristics of the plain text, or we have some plain text ciphertext pair also. So from that the hacker will try to find out what is the plain text for a given ciphertext pairs. Brute force attack. The attacker tries every possible key on piece of ciphertext until an intelligent translation into plain text is obtained. On an average, half of all possible key must be tried to achieve the success, but every time brute force attack is not possible, so hackers are always taking the different approaches. Now see the example for the brute force attack. Try every key to decipher the ciphertext. On an average, hacker need to try half of all possible keys to get the success. Time needed proportional to the size of the key space. So see the example. If the key size is 32 and the key combinations are possible 2 raised to 32, if hacker use one decryption per microsecond, then it requires to only 35 half an hour, and if it uses the operation like 10 raised to 6 per decryption per microsecond, it just require the 2.15 millisecond. But as the key size increases, so number of possibilities are more, so hacker require more and more time. But in this case, hacker still decrypt the system because it is not going for this brute force approach, but different approaches are there. For example, 26 permutation. So here possibilities are 26 factorial. The number is very big, but if attacker perform the frequency analysis, this particular type of encryption method can be easily hacked by the attacker. So this is all about the basic terminology of cryptography is explained in this video. Thank you.